Hello, NE204. What we will cover in this series of lectures is Lab 13, Networks in Neuroscience. And what we'd like to do in this lab is develop some techniques to analyze networks using MATLAB, and also to take the networks that we drew in class, as well as other networks, import them into MATLAB, and then start manipulating them. And so what we'll look at today are 4 measures of networks and how to apply these measures. And let's start by constructing a simple network. This will be a network that we discussed in class. You can get a picture of this network from Blackboard Learn. It's called net1.jpg, and I've loaded up that picture here on the left of the screen. And what we see is that this is a network. We can ask questions about it right away through visual inspection. We can ask how many nodes are in the network. That's the first question. We can again see this through visual inspection. We can count the number of nodes, or just look at the numbers. We see there are 1, 2, 3, 4, 5 nodes in this case. We can also ask a simple question, one of our measures: how many edges are there in the network? And again, through visual inspection, we're able to deduce how many edges exist. In this case, there are 1, 2, 3, 4 edges in this network. So those are pretty simple questions we can ask through visual inspection. But if we'd like to do more, especially as the networks get more complicated, we'd like to take this network, this picture of a network, and turn it into something that MATLAB can read in or understand. And the way we'll do that is eventually by creating a matrix. We can think of lots of ways to represent this network. We might try to list all of the pairs of nodes that represent edges. For example, we could list there's an edge between node 1 and node 2, and we could represent that with an ordered pair. We could also represent the structure of this network by saying there's an edge between node 1 and node 3, node 1 and node 5, and node 1 and node 4. And again, we can list all of these ordered pairs to represent where the edges occur. Now, of course, because we have an undirected network, we could just as well represent that an edge exists between nodes 2 and 1. It's the same as nodes 1 and 2. The order doesn't matter in this case. It's irrelevant. All we care about is that an edge exists between node 1 and 2, or equivalently between nodes 2 and 1. So that's one way we could try to represent this system. But again, let's go back to this idea and represent this network instead as a matrix. And the way we'll do that is we'll define a new empty matrix. Let's define that matrix as A. So here's our matrix A. We can look at it right away and we see it's a 5 by 5 matrix that consists of all zeros. And what we'd like to do is fill in this matrix, create an adjacency matrix that represents the network that we've drawn in the picture above. And the way we'll do that is we'll think of each row as corresponding to a particular node. So we have rows 1, 2, 3, 4, and 5. And each column also corresponding to a node, columns 1, 2, 3, 4, and 5. And what we'll do is fill in this matrix with zeros and ones, where 0 indicates that an edge does not exist between a node pair, while a 1 indicates that an edge does exist between a node pair. So what we'd like to do is let's first update and include in our adjacency matrix the edge between nodes 1 and nodes 2. And the way we'll do that is we'll update A, and we'll specify that we'd like an edge to exist between node 1 and node 2. So we'll set that value instead of 0 to 1. And we can do that. And because we want our matrix to be symmetric, we don't care about the ordering of the edges. We'll also place another edge here between node 2 and node 1, and we'll set that to 1. Good, so that specifies one edge in our picture, now in our adjacency matrix. And if we want, we can look at our adjacency matrix again. I'll just hit A at the command line, and we see that we now include a single edge. And remember, our matrix is symmetric. This edge indicates, or this 1 indicates an edge between node 1 and node 2, so row 1 and column 2, or equivalently an edge between row 2 and column 1. It's the same thing. And what we'd like to do is update this matrix. So this is the next in-lab question. Let's update this adjacency matrix to include all of the edges in the picture. And how do we do that? Well, we'd like to include an edge between node 1 and node 3. So let's set that to 1. And between node 3 and node 1. So let's set that to 1. And that indicates this edge between node 1 and 3. What about between 1 and 4? We'll do the same commands. I'll hit up arrow here twice to get back to 1, 4. We'd like to include an edge there. And between 4, 1, we'd like to include an edge there. And that's the third edge in our network. What about the last one? We have the edge between node 1 and node 5, and node 5 and node 1. And that creates our adjacency matrix. We've now taken this object, this network that we have a picture of, and put it into something MATLAB can read, in this case a matrix. There are different ways to visualize this adjacency matrix. I now outline 62 in our code. How do we do that? Well, we can print it out at the command line by just looking at A. And we can read off where the edges exist. So where are the ones? They're between node 1 and all other nodes, nodes 2, 3, 4, and 5, or equivalently between node 2 and 1, node 3 and 1, node 4 and 1, node 5 and 1. And notice again, this matrix is symmetric. We can see A1, 2 is equal to A2, 1. And similarly for all other pairs of nodes. So that's one way we can look at it. Another way we can look at it, if we look at lines 74 to 75, we can execute this SPY command. So I'll do that here. And what we find in this case, this is a representation of the nodes in our network. It's not the greatest figure, but it gives us a visual representation of our adjacency matrix where we have nodes on the vertical axis and node number on the horizontal axis. It also includes 0 and 6, right, which is not useful for us. But what we can see here, the blue dots indicate edges. We see there's an edge between node 1 and node 2, node 1 and node 3, node 1 and node 4, and node 1 and node 5. And that this thing is symmetric. We also have edges between 2 and 1, 3 and 1, 4 and 1, and 5 and 1. So this matrix A that we've created is called the adjacency matrix. Value of 1 indicates an edge between a node pair, while a value of 0 indicates no edge between that node pair. This matrix is always symmetric, so that Aij is equal to Aji. We can flip this thing over along the diagonal and we get the same picture.